So I actually lost my video for this because I couldn't remember how to close the video, which was great. So here's 10.4, the dot product. The definition of the dot product is vector v dot vector w. This is why before we did not write dots or crosses, is because later we're also going to have a cross product. Is the component v1 times the component w1 plus component v2 times component w2, so on and so forth for all the components you have. The properties of the dot product, you have the magnitude property, which is actually really interesting because the dot product gives you a scalar quantity, and so if you think of it that way, this, by dotting a vector with itself, you're squaring it, but you're wanting a scalar value, which is what you'll get, but it's the same as just taking the magnitude and squaring it, because that's a scalar and you're just squaring the scalar. And it's commutative, distributive, and it has linearity, which means that you can put the scalar a with vector u or vector v and dot them that way. But do not distribute the a, because then you're going to be accounting for it twice, and we don't really like that. And then the zero vector property is just the zero vector dot any other vector gives you a scalar 0. And this is the angle between vectors. It's used for like boat problems, which I don't like. And if you don't know what I'm talking about, just ignore me. It's like a running joke. Cosine theta equals vector v dot vector w over the magnitudes, or the product of the magnitudes. And if theta is 0 or pi, the vectors are parallel. And if theta is pi over 2, the vectors are orthogonal, which means like perpendicular in space. It's just a fancy word. And if vector v times or dot vector w equals 0, the vectors are also going to be orthogonal. Find a vector in space from its magnitude and direction. This is like that Amy and Johan thing, where they're just wrong, saying that they don't have their vector even though they have all these other things. So vector v equals its magnitude times cosine alpha I plus cosine beta j plus cosine gamma k, with cosine alpha being vector v1, or not vector v1, component v1 over the magnitude of the vector, cosine beta being component v2 over the magnitude of the vector, and cosine gamma being component v3 over the magnitude of the vector. Vector projection, I actually hate just a little bit, but the projection of vector v onto component, vector w equals vector v dot vector w over the magnitude squared of vector w times vector w, which actually is like the first component of your new vector, and the second component is going to be like your total thing minus v1. It's going to be nice. It's very nice. And don't worry, we'll do some practice examples later to make that make sense. So work, we all know, is force times distance. So all this is saying, hey, your vector force, or force vector, dot your distance vector equals work. Yay! Simple things that we all know and love. Anyway, that's the end of this video, and I will see you guys in the next one.